Alrighty then, corn children. We're going to do more practice finding derivatives using the definition of the derivative. And today we're going to look at a technique of common denominators. Campers, this is the same technique you learned in elementary school. We're just using it in the context of derivatives. So this is not that bad. All right, equation of a line. We need two things, don't we now? We need a point and we need a slope. Well, the point's easy enough to do. They've told us the function, they've told us the x-coordinate. To get the y-coordinate, we simply fill the x into the function. So the y-coordinate of our point will be f of 2. We fill in 2 right here. We get 2 over 4, which reduces to 1/2. So now the point is 2, 1/2. And we'll come back to that. We don't really need it yet, but there it is. What we do need is the slope. Well, how do you find the slope? The derivative. We're going to find the derivative and then fill 2 into it. All right, so here's where this gets a little bit messy. Now, think ahead, people. We are working with a fraction and the definition of the derivative itself. F prime, limit delta x approaches 0 is a fraction. F of x plus delta x minus f of x all over delta x. So we're going to be putting a fraction into a fraction. Space out, people. Not like mentally. Give yourself some room. Here we go. Limit delta x approaches 0. All right. F of x plus delta x means I take this x out and replace it with x plus delta x. I'm putting this into the denominator of this fraction. Careful with the negative sign there. So it is 2 over 6 minus all of that. You need a parenthesis or you need to distribute right away. That's f of x plus delta x. It is in the numerator of our difference quotient minus the original function all over delta x. All right, you with me here? All right, so just to make our lives better, I'm going to write this again, distributing the negative ever so carefully. You don't want to drop any of these signs. It'll mess things up. All right, limit delta x approaches 0. This is 2 over 6, distribute the negative, minus x minus delta x. Now, because we're going to do common denominator work, I'm going to leave myself some room here, and then the minus, and the 2 over 6 minus x, all over delta x. All right, I am going to get a common denominator here. No, there's no fancy shortcut of just tacking a minus delta x here. We have to multiply by forms of 1. So the first fraction is going to be multiplied by the form of 1, 6 minus x over 6 minus x. The back fraction will be multiplied by a form of 1, 6 minus x minus delta x. There's no way around that. Now, do you see this little delta x? It's feeling left out. Everybody's a fraction except me. And if anybody's a fraction, we like to make everybody a fraction. All right, so now this algebraic mess needs to be simplified. Well, we already have our common denominators. If you're not convinced of that, look, this and this, this and this, they are the same. So I'm going to keep that as the common denominator. Listen, do not multiply out the denominator. Leave the denominator in factored form. This is the common denominator. All the work is in the numerators. So what's in the numerator? Distribute the 2. 12 minus 2x. Distribute. Now, if you're going to mess up, here's where it's going to be. Do you see this minus sign? Do you? Are you looking at it? Look again. You need to distribute both the 2 and the negative. If you're going to botch this up, then think of it as adding a negative 2, right? It is negative 2 Distribute, distribute, distribute. All right, here we go. So this is negative 12, positive 2x, positive 2 delta x. Now, you see this? We are dividing by this fraction. How do you divide by a fraction? You multiply by a reciprocal. Flip and multiply. There's the multiply, oh, the flipping. You see it? All right, look at that numerator. Silly numerator. 12 and negative 12. That's so funny. Negative 2x and positive 2x. Hey, if those signs aren't opposite, you screwed up. Every term that doesn't have a delta x needs to cancel out. It's a way to check your own work. All right, so what do we have now? Well, the numerator is factored. What? It is a positive 2 multiplied by a delta x. The denominator is factored. It's this multiplied by this multiplied by this. It is already factored. We are already to the factor. Now we can cancel. The delta x's cancel. And now we plug delta x equals 0 back in. We let the remaining delta x, which is right here, head off to 0. So what's left? Now be careful. See that 2? It's still there. Yeah, it is. And in the denominator, we have 6 minus x, that goes to 0, times another 6 minus x, also known as 6 minus x squared. Hello, little derivative. Aren't you cute? Now, let's be clear. This is not the slope. This is the slope machine. We wanted, I'm sure you forgot already, we wanted the equation of the tangent line at 2. We don't want a slope machine. We want the specific slope when x is 2. Also, don't forget our point was the point 2, 1/2. All right, so if we want the slope at 2, to get the slope, we need to fill 2 into the derivative. So this ends up being 2 over 4 squared. That's 2 over 16, which reduces to 1/8. So from earlier, we have our point, we have our slope, point-slope form. Y minus the y coordinate, m times x minus the x coordinate. Tangent line. Booyah.